In an earlier video, we mentioned that the sine, cosine, and tangent functions were the primary functions, and that cosecant, secant, and cotangent were just their reciprocals. We can rewrite these relationships without referring to the sides of triangles. Taken collectively, these formulas are known as the reciprocal identities. Even though there are 6 formulas, you really only need to know the first 3, since you can get the others by simply taking the reciprocals. There is another collection of formulas, known as the quotient identities. These show some more of the relationships between the different trigonometric functions. And even though there are 2 of these, you really only need to know this one. Again, you could derive the other one by taking the reciprocal. There's one new formula that we can get by looking back at the unit circle. Remember that every point xy on the unit circle corresponds to some angle theta for an angle drawn in standard position. But if we remember that the formula for the unit circle is x squared plus y squared equals 1, and we remember that x corresponds to cosine theta and y corresponds to sine theta, then we can make a substitution to get cosine squared theta plus sine squared theta equals 1. This gives us another identity. However, the conventional ordering happens to be sine squared theta plus cosine squared theta equals 1. The notation for raising trigonometric functions to different powers can be a little bit confusing at first. The reason we write it this way is because sometimes we get lazy and we don't write the parentheses around the angle. If we put the exponent at the end of the function, it would be unclear whether the exponent was being applied to the angle or to the function itself. Fortunately, the notation isn't too difficult to get used to. We can derive 2 other identities from this one by dividing through by either sine squared theta or cosine squared theta. These formulas are collectively known as the Pythagorean Identities. The first one is the most important one to know because the others can be derived from it. We will have many uses for these formulas. One of those uses is to verify trigonometric identities. All this means is that we show that 2 expressions actually represent the same value by performing algebraic manipulations and substitutions. For example, we will verify that 1 plus sine theta times 1 minus sine theta is equal to cosine squared theta. The general approach to these problems is to start from one side of the equation and work our way to the other side. It is usually best to pick the side that looks more complicated and try to move towards the simpler one. In this case, the left side looks like the better place to start. We are only allowed to do basic algebra and make substitutions based on our previous identities. For this problem, the only reasonable starting point is to multiply it out. If you recognize this combination as a difference of squares, you can jump straight to there. Otherwise, just FOIL out the product of binomials. There are a few different ways to figure out where to go from here, but the simplest one is to use the Pythagorean identity to substitute for the 1. Then the sine squared theta terms cancel out, and we are done. We could also have manipulated the Pythagorean identity on the side and used the new formula as our substitution to complete the calculation. When you do this, you need to be clear about what substitution you've made, because otherwise it looks like you just wrote down the final answer. Remember that communication is an important element of mathematics. And it really doesn't matter which way you do it, as long as you communicate it effectively. We will verify more trigonometric identities when we start working on analytic trigonometry later on in the course.